Okay, today's notes is on 4.8, isosceles and equilateral triangles. Now, the first theorem in this lesson is base angles theorem. Now, remember when we had an isosceles triangle and we learned what isosceles triangle is, it's a triangle with two equal sides. Okay? But if it has two equal sides, the base angle theorem is that there will be two equal angles. So a triangle with two equal sides and two equal angles. Now the two angles are the ones that are on the base. In other words, the side that is not equal. So if you have your two equal angles here, sides, excuse me, the two angles will be the two angles that are on the base. This is the base. Okay, the base is the non-equal side. Okay. So the two angles there that are congruent are called base angles. Okay, so the two angles on the base are base angles. Those are the two angles that are congruent. They're always opposite the two congruent sides located on the side that is the base, the non-equal side. And the equilateral triangle, we've already covered this numerous times now, so a lot of it's repetitive. But in an equilateral triangle, we have three equal sides and three equal angles, which are all 60 degrees. So three equal sides and angles. So we can use the relationship we learned about angles and sides and use that to our ability to solve for either a variable missing side or a missing angle measure. So let's look at example 1. So in example number 1, okay, we have two equal angles, which means this is an isosceles triangle. This is the base. So since this is the base, it means these two sides are the equal sides. Okay, so we know that AC is congruent to CB. So I can just set 12 equal to 2x minus 2 to solve for x. So I just add 2 here. Gives me 14 equals 2x. Divide by 2. So x will be 7. And I got my solution. Okay, and let's switch over to, okay, so what we're going to do here is change up example number 2 because there's an error on it. So what you want to do is replace the W and the 50, just reverse them. So this is now W and this is 50. And then let's solve it. So after you made that change, what we're going to do here is we're going to look at this triangle right here, the first one. And it's isosceles because two sides are equal. So if these two sides are equal, then I know that Z and 50 must be equal. So this angle here will be 50 degrees. So Z equals 50. I can then find V because these three angles will add up to 180 degrees. Because every triangle, interior angles add up to 180. So V plus 50 equals 180. So V is 80. I can then find x because these are forming a linear pair. Okay, and so therefore, if this is 50, this has to be 130. So x equals 130. And then I can find y and w because I know that these have to be equal. okay, because this is isosceles, so these two angles are going to be congruent. And I know they're going to add up and equal 50, because the exterior angle equals the sum of the two remote interior angles together. So what two angles are the same measure? When you add them, you get 50. Well, you just take 50 divided by 2, which is 25. So each one of these is 25. So W equals 25 and Y equals 25. And there are your answers for that one. And again, you can just verify 25 plus 25 plus 130 equals 180. And so that triangle is correct. Okay, and let's finish this out with example number 3. So I'm going to first give you some time to try to solve that yourself, and then we'll go over it. Okay, so example number 3. The first thing I want to do is start with this equilateral triangle here. I always know that in an equilateral triangle, all the angles measure 60 degrees. So x must be 60. So this is 60, 60, and 60. And then these are angles right here are forming a linear pair. So z must be 120. And this is isosceles triangle here. So these two base angles are going to be equal. So all I gotta do is take 180 minus 120, gives me 60, and then divide it by 2 because these both have to be the same measure. So 60 divided by 2 is 30 and 30. So y is 30. And there's my answers. And that concludes today's lesson.